Welcome back, everyone. So today, we're diving straight into this explainer on two absolute game changers in Python, dictionaries and loops. We're talking about organizing complex data on one hand and mastering control flow on the other. If you're looking to write code that's not just clean, but super efficient and scalable, well, these are the tools you absolutely need in your toolkit. Let's just jump right in, shall we?
Okay, let's take a quick look at our roadmap. We'll start with why we even use Python dictionaries, then break down keys, values, and the syntax. After that, we hit the power of loops. And finally, we'll master both the while loop and the for loop.
All right, Section 1. Why use Python dictionaries in the first place?
Picture this. You need to store details for a single user, right? You've got their name, their age, and their city. Now sure, you could store these as three completely separate variables. You know, name equals Hamza, age equals 25, city equals Karachi. But what happens when you get a second user? Or, I don't know, 100 users? Suddenly, you're drowning in hundreds of totally disconnected variables. It's an absolute nightmare to manage.
Now your first instinct might be, hey, I'll just toss all those details into a list. But here's the catch. Lists are really built for storing the same type of data, like a list of 3 student names or a bunch of fruits. If you just throw Hamza, 25, and Karachi into a list together, well, anyone reading your code 6 months down the line is going to have no clue what those random items actually mean, and that is exactly where the dictionary swoops in. It's literally the perfect solution because it lets you group all those totally different properties of a single entity into one cohesive, readable package.
Moving on to Section 2. Let's talk about keys, values, and syntax.
So, at the very heart of a Python dictionary is something called a key-value pair. Think about, say, a physical university register. At the top of the columns, you've got headings like name, subject, or roll number. Those headings, those are your keys. Then the actual specific info you write under them, like computer for the subject or PIAC for the roll number, those are your values. A Python dictionary is just taking that exact real-world, everyday logic and dropping it straight into your code.
Let's actually break down how you write one, step by step. Building a dictionary from scratch is surprisingly easy. First up, you just open with curly braces. That's your way of telling Python, hey, dictionary coming through. Step 2, you write out your keys, and you wrap those in quotes just like a regular string. Step 3, drop in a colon and then put your value right after it, and that value can be anything. A string, a number, whatever you need. Finally, step 4, just separate each of those key value pairs with a comma. Boom. Clean, readable, and super structured.
Okay, so once you've got this set up, actually using it is a total breeze. Want to grab a specific detail? Easy. Just pull the dictionary's name, add square brackets, and pop the exact key inside, like user1, bracket subject. Now, what if you need to update a value? You just use that exact same bracket notation and set it equal to your new data, like bumping the age to 15. And honestly, the best part is that adding a completely new property uses the exact same syntax. Just invent a new key, let's say country, set it to Pakistan, and Python just magically pops it right into your dictionary. Simple as that.
All right, let's shift gears to Section 3, the power of loops.
If there is one golden rule in programming you need to memorize, it is this. Don't repeat yourself. The dry principle. Seriously, if you ever catch yourself just copy-pasting the exact same lines of code over and over, you're definitely doing it wrong. And that right there is exactly why loops were invented. Think about how things work in the real world. Clocks, ceiling fans, washing machines, they all operate on continuous cycles, right? They just keep doing their specific task over and over until some condition is met or until you literally pull the plug. Well, in Python, a loop does the exact same thing. It just spins through a cycle of instructions for you, completely automatically.
So let's look at how to actually use them in Section 4, mastering the while loop. Imagine you're trying to code a New Year's Eve countdown, 10 down to 1. Now the absolute worst, most manual way to do this would be writing out print 10, then hitting enter, print 9, then print 8, all the way down. I mean, not only does it totally violate our DRY principle, but it's just painful to write, right?
So instead, we use a while loop. The logic is actually super elegant. Step 1, you just set a starting variable. Let's say countdown equals 10. Step 2, you write the keyword while and give it a condition. Here we'd say while countdown greater than equal to 1. Step 3, you tell the loop to print that variable. And step 4, and this is absolutely crucial, you subtract 1 from your variable.
So as long as that condition stays true, the loop prints the number, drops the value by 1, and jumps all the way back to the top to check the condition again. But watch out, because this is where a lot of developers fall into a pretty dangerous trap. What happens if you forget step 4? Like, you just forget to subtract the 1. Well, that condition is going to stay true forever. Your code will just start spitting out 10 infinitely. The source material actually highlights this perfectly. One tiny mistake like that, and suddenly your loop rockets down to negative 200,000 in a fraction of a second, and boom, your whole browser freezes and crashes. It's wild. So yeah, always make sure your while loop has a way for that condition to eventually become false.
Okay, let's look at the other side of the coin in Section 5, Mastering the For Loop.
So the big question is, how do you know when to use which? It basically boils down to this. You use a while loop when you're relying on a true or false condition to keep the whole thing running. But you bring in a for loop when you already have a known collection of data, like a list, and you just want to iterate through it. The for loop is literally custom built to run exactly as many times as there are items in your sequence.
Let's look at a quick example to make this concrete. Say we've got a list of numbers, 1, 2, 3, 4, 5, and we want to square every single one of them. A for loop just elegantly steps right into that list. On cycle 1, it grabs the 1, squares it, prints it. Then, and this is the magic part, it automatically moves to the next item. It grabs the 2, squares it to get 4. Then 3 becomes 9, 4 becomes 16, 5 becomes 25. You notice what's missing? There is no manual counter. The for loop just seamlessly flows through the data entirely on its own.
So, just to summarize what's actually happening under the hood here, for loops always kick off at the 0 index of your list, and they automatically know exactly when to stop, which is simply when they hit the end of the sequence. So you completely avoid that terrifying infinite loop danger we talked about earlier. Plus, you just define a temporary variable right there in the syntax, something like for num and numbers, and Python does all the heavy lifting, assigning the current list item to that variable for you as it goes. It is just incredibly efficient.
Wow. Okay, we have covered some serious ground in this explainer today. We've mastered structuring properties with dictionaries, and we've learned how to completely automate repetition using loops. But before we wrap up, I want to leave you with a little bit of a provocative thought, sort of a challenge for your next coding session, inspired by the source material. Think about this. If a dictionary is the perfect tool for storing the complex details of one user, and a list is perfect for storing a sequence of items, how would you elegantly combine those two structures to manage a database of, say, 100 unique users? Really think about the power of nested data structures there. It's a fun puzzle. Good luck with it, and keep on coding.